Alrighty. Paul's shop. Met airplanes all over.
But not at Paul's.
Well,
No, that's true.
these are my latest 3.
Yeah.
I whipped these out this weekend.
Yeah, I pulled them out of the garbage can. This is where it all began, eh? This is where you would fill in the blank and talk to people that are really on the other side of the camera.
The blank. Okay,
Yeah.
I'm blank.
Right.
This is where it began.
Actually, we've got a little bit of glare coming off the top of your
Actually,
head
you want
there.
to go fill where it began, and you go a couple
Now,
rooms
this guy
over.
wants information. He starts making cracks about the glare on the head.
Well, I know you don't take anybody seriously unless you get hammered a little bit.
This isn't it.
Yeah, yeah.
Oh, you have to see where Ruth started.
Huh?
You'll feel terrible about the big work eatery you got at your house.
Yeah, there you go. So the top one was bad news?
That is the bad news from '87. I do not have the original bad news anymore. Met with an unfortunate accident.
Uh-oh.
The second one down is the impact that's won 3 nats at team trials in the world champs.
Well, that's the world champ one.
Yeah,
Right?
I have some sentimental tie to it. This
Oh,
one, on
yeah.
the other hand, is like the exact opposite of the one above it. It has never won a single contest, be it even a local contest in its life. A sad commentary. I don't fly it much anymore.
Hmm.
The next one down, of course, is the one that went to Sweden. It has fared only slightly better than the other one in terms of winning anything.
And that's the one that we,
Came in second at the world champs, and
oh yeah.
it finally won a contest. Won a contest. Else.
For the Sweden airplane?
Yeah, well,
So that's the little half A 049 jobby back there that you were talking about? No, okay.
that's, oh yeah, and
And then this is the current one here.
this is the latest and greatest.
Hmm.
Hmm.
You spelled PA60 wrong on the nose there.
Oh, jeez. Sorry, Randy.
Yeah.
Dang.
Yeah, I was noticing in a photograph of,
There's a little red regulator inside there, and so the bladder pumps the fuel out to the regulator. The regulator is tied to the muffler pressure.
oh,
And,
okay.
and so it senses the RPM and the back pressure, and it regulates the fuel to the engine. And there's one of those on every engine.
Hmm.
So,
Well, it makes flying multi-engine stunt virtually simple.
virtually simple.
That's it.
Absolutely. Spoken from someone who has never.
No, absolutely not. Nor will ever, I think, is the point. So we just use these little bladder thingies, eh?
Yep.
And this is a previously exposed bladder?
That's a different type, but it's another one that I used.
Mm-hmm.
I've run them in that would want to break the 2-cycle once you flew it. Nothing you could do to stop it. But with the bladder and regulator, it'd hold 4-cycle up to about 10.2, 10.3, and it held it in flight. And it had this 4.24 brake when it flew, and it'd come up, and it'd actually brake in 2-cycle, and it was in the right places.
Mm-hmm.
And it was very interesting. It worked real well, and then fly in the wind didn't speed up at all. So you knew the regulator was doing something if it didn't speed up in the wind. They're
Yeah.
terrible at that.
What prompted you to decide to do that? Just
You
Why
mean
not?
build a B-17?
no, the bladder regulator.
Oh,
issue.
because I had 4 separate tanks in there before, and that was a nightmare.
Yeah, but I mean like on the Super Tiger 60.
Oh, why?
Hmm.
Just for the hell of it. I wanted to see. I was running them on 40s before I even put them in here. I have OS 40 FSRs I was running them on, and they ran real good on that. Actually, everything I hooked them up to and ran amazingly well on it. So I thought, what the heck, I'll try to run an engine that was already made to run 4-cycle and see what happens. It ran real good.
So why not run it on a pipe ship?
Well, it's like having 2 governors on a system. What you have is a pipe trying to govern the thing, and you've also got the regulator, and under certain circumstances they'll fight each other.
Mm.
Not good.
Right, okay.
Because one of them's going to win, and when one wins, the engine. I intended to. Randy's 60 will work, and that's another one I want to do is put a muffler on it, just in the back. and put it on a bladder and regulator and see just how well it'll run. I don't see why it won't. But another project for another day. We'll
Yeah.
do that after I probably do the Heinkel.
Was that next on the list?
I think so. Well, I gotta get my little Cobra built, and
Mhm.
I'll start designing the Heinkel and start getting some work done on it. But
Mhm.
I think that's my next project.
What's gonna power the Heinkel again?
Two of those Tower 30s, what was it, the Thunder Tiger 36s.
Right.
And, yep, that'll be, should be plenty of power. So, yep, it'll be in between one of these sizes and the B-17 size.
Mhm.
I'm guessing 68 inch wingspan, 800 square inches. Around 70 ounces, it should fly pretty good.
Mhm.
Is there a maximum displacement for multi-engine?
Yes,
I don't remember what it
72.
is. Oh, perfect.
72 divided by 2 is 30. It was the rate rule. It was made many years ago.
Hmm.
The rule, it used to be 65.
Mm-hmm.
Well, at the time, there were no 32s available. There was no 30s to speak of that were any good. There really weren't anything good that you could make two of. And so Ray wanted to build a twin, so he had the rule changed to, because Fox made 36s, so they
Mhm.
made the rule to be 72. So that's why it is. So these 36s should work.
Mhm.
So, but I think it'll be plenty of power on a 70 ounce airplane.
Chances are.
Chances are. So yeah, fun project, and it'll be take apart job like the rest of all the other airplanes, and
Mhm.
it'll have the glass cockpit. I want to put the glass cockpit in there with the little guys in there and all the instruments and things. And
Start both up on a center bladder again?
No. A twin, I'm not going to waste my time with a bladder. The two tanks will work fine. One of the problems with the B-17, I don't know if you heard, is that the 4 engines, they'd use different amounts of fuel at each engine location.
Mhm.
Everyone used a different amount when you had separate tanks on there, so you had to very carefully. So this, and I think the 3 position used 2 ounces of fuel, 2 position used 1 ounce. It was that different.
Holy man.
And that was to get it all to quit relatively at the same time. And so once you go to a bladder and regulator system,
That'll just.
all that goes away. But with a twin, you don't have that problem.
Mhm.
It won't act like that. So tanks will be fine. I prefer the tank system. A little less headache. So yeah, that's probably the next project. We'll see.
Right on.
I've got no desire right now to build another one of these.
Well, you've got a couple of dozen. What, you both have different approaches to the same solution. What was your design criteria when you started?
My design criteria when I started, I don't know.
What were you trying to achieve? Like, you obviously both used the large area, low aspect ratio stabs. Both of them have fairly thick center section airfoil. Dave, yours is 18.5 inch tail moment. Yours is 17.5.
Mm-hmm. Mm-hmm.
Any thoughts on that?
Oh, I wanted to start out with a thicker wing
Mhm.
compared to what I was flying at the time. So I went to a thicker wing because I wanted to carry more power while I was flying. And so that the difference between turning up and turning down wasn't so significant. If you have no drag when you turn up, you got thrust, drag, and weight.
Mm-hmm.
So that if you increase the drag more and more and more, when you make the difference between here, going uphill you got drag and weight. When coming down the other way, you got drag is that way, but thrust and weight are this way. So there's a significant difference.
Mm-hmm.
And if you increase the drag, obviously to the limit where it's the dominating factor, there's no difference between up and down. Obviously we're not going to increase the drag that high, but increasing the drag will decrease the difference between the two. So that was why I went to a thicker wing. And
Mm-hmm.
the lower aspect ratio tail wasn't originally, it was originally on the impact, it wasn't originally on the bad news.
Mm-hmm.
They were kind of a similar shape to the wing, but
Is that a result of seeing Atkinson's laser?
part of it, I'd thought about it but never had done it, but then I saw Gibbs fly, but his had the little braces on it.
Mm-hmm.
And it wasn't so much, I think that worked well because of the braces as well. That really supported it, and it showed that a stiffer stab seemed to work, and the aspect ratio of the tail isn't nearly as important. And
I disagree a little bit with that.
Anyway.
Because I played a little bit with that and the different tails in the other airplane,
mm-hmm.
and found that even small changes in the aspect ratio affected the way the corner, the quality of the corner. The lower the aspect ratio went, the more solid the corners went, but of course the more elevator I needed because of the shorter elevators.
I was just getting to,
There's a happy medium in there.
I think the difference is that as you get to a lower aspect ratio, the tail becomes stiffer. Obviously, there's
Right.
less and less mass,
Okay.
so there's less deflection, and the smaller deflection makes it relatively stiffer, and it gives you that feel. So that was my approach, was just to shorten the span of it and
Oh,
keep
okay.
the same area, so it would stiffen it up and give you that same type of corner that Git had with all the locked-in features. So it stiffens it up significantly. So that's why I went to that. The tail length, it just happens to be what I designed in 1982 or whatever, when I built the first Bad News. And
That was a fairly significant departure from planes of the day, though, wasn't it?
there were a lot of planes out there very much like that. There was no, I wouldn't say it was any kind of departure at all. No. There were,
Do you feel that longer tail moments or shorter tail moments or anything like that has any particular advantage one way or the other?
probably does, but I haven't played it. Dave's running his longer.
Well, frankly, the reason mine's longer is to balance it without using lead. That's the main reason, to be honest.
Mhm. What was the reason I lengthened the tail on that airplane? So I had lead in the other airplane. I thought, well, that's stupid. Why don't I move the tail back?
So.
What about molding and the new High-Zoot compounds like molded Kevlar and carbon fiber and all that kind of crap? Is there any future for that?
If there is, it will be very difficult, and it will come at quite a price, money-wise, as well as
Mhm.
time-wise. It's hard to beat balsa wood with the dimensions that we have when you got depths and widths like you have on your typical wing and fuselage.
Mm-hmm.
It's really hard to beat balsa. It doesn't take very long when you sit down and compute. You look at just the wing area of this and made that one layer of carbon. The weight of that adds up real fast.
Mm-hmm.
And so you can't hardly have just one layer of carbon. It's just not stiff enough, and it won't take any compression load on it. Whereas the balsa being less stiff,
Cross-sectional
it's
thicker.
thicker
Mm-hmm.
for the weight, and it has a much better compression strength than a single layer of carbon would. So anytime you've got a size for compression, which is
Mm-hmm.
obviously when you do any kind of maneuvering, one side of the wing is going to get it, and the other side is going to get tension.
Mm-hmm.
It's better to have a thicker material in there that's less dense. It will be more stable. And so it gets really hard to beat a balsa. The closest thing I can get to it's with the I-beam wings, the carbon spar in there.
Mm-hmm.
It's rigid enough. It seems to hold up well and not deflect in the maneuvers, and gets rid of some of the wood, but you still got all the ribs and whatnot in there.
Mm-hmm.
So
Does your carbon I-beam airplane have carbon trailing edge and leading edge as well?
No.
Just the spar?
Yeah, the spar carries all the load in that airplane. So
Do you feel there's any torsional changes happening to the wing as a result of that? Do you think the tips would pivot on the spar?
no, you got to make sure you've got a good covering on there, and it's
So
well
covering
stiffened.
then becomes
Absolutely.
significant
Oh,
part of the
that carries all
torsion.
the torsion loads. Yeah.
Mm-hmm.
Absolutely. Now, one thing Howard and I have considered doing, and we haven't got to it yet, is to make a carbon tube spar. And he's done that with his combat planes. We just haven't had the time to do that with one of these. We're seriously thinking of giving that some effort. You can put a carbon tube in it. They'll carry all the bending loads. Once you hook them together, and you can put your ribs on it. Once you attach all that, you instantly got all your torsion strength right there because of the tube.
Mm-hmm.
And it being carbon is very rigid in that mode. So you wouldn't have to rely on your fancy cover. You could have more of this type of rib arrangement, much fewer ribs and whatnot to get the job done. So there's something to be had there.
Mm-hmm.
But in terms of fuselages, and it's just hard to beat what we got there.
Ted and I played around with the vacuum bagging and the carbon veil with a resin finish on it to try and get basically a ready to paint finish to try and reduce or offset the weight of the carbon in the resin. And it ended up being heavier than sheeted balsa in traditional dope finish. It was rigid as hell, but the weight penalty I think was too high to be used in an all-out competition or anything.
And Howard, on his impact, built a carbon cowl. He obviously wanting to always improve and not do the normal, he decided to build a carbon cowl. So he made the mold and all that. And without asking me what it should weigh, he just built it. And he got it all done and says, "Gosh, I got it all and this is great, and it only weighs 27 grams.
Yeah.
Howard, 27 grams. I said, "Here, my cowl over here, 15 grams or whatever, He says, "I don't have any paint on it yet." I said, "This is a finished one on the airplane." He says, "Well, I obviously have to go back to the drawing board here." He got it down to 18 or 19 grams with paint on it. No, with the paint on it. But it is so flimsy.
Yeah.
You can't reach down and pick his airplane up here. The whole cowl buckle, you can't go anywhere near the cowl. It's very, very
You can't
flimsy.
do that for cowls. They in and out of them all the time. They got to be one of the tougher things on the
Yeah,
airplane.
so he had it was there, but so I mean on a cowl, that to me is one of the more less weight efficient parts we have on the airplane, because you carve them and you're always leaving a little extra meat in these things to make them tough, and yet the balsa one was still quite a bit lighter than the carbon one. It's going to be a hard chore to build this out of fiberglass or carbon or something. A lot of people have tried. I know Admissions have worked at it, but they were terribly heavy. Terribly heavy.
Well, you experienced with the really, really light impact, perhaps an airplane that was too light. Is that the way you would describe that?
For the given geometry that I have on the airplane, yeah. It may be that one of the things I want to do is go back and remove the flaps and put smaller flaps on it. It's another experiment to do. I've already tried adding weight to it to see, and it seemed to respond some to that, but I need more time to trim and work with it. But I think with the given geometry that I'm running, it wants to run at the heavier weight. Now, I'm going to try the smaller flaps and see what happens. That may help it.
Try Trivial Pursuits, I suppose.
Yeah, just reduce them and see what happens. You never know, it may work. So you may build your airplane and you could build 2 or 3 sets of flaps and see, okay, this is a 58 ounce flap, this is a 50 ounce flap, over here's a 62 ounce flap. Oh yeah, you can see that. But
Well, this thing at the lighter weight, I do have to practice to stay good at it, but my Sweden airplane at the heavier weight, I could just pick it up and start banging away.
Is that familiarity or is that inherent design?
The Sweden airplane's really kind of a baby. It's only got 400 flights on it. And the others are 600, 800, 1200. This one's only about 220 right now. But it just feels much more solid and more consistent on the exact same power plant setup. It's got the airfoil tail in it right now, and I think that's the best combination for the other airplane. That may have quite a bit to do with it. If I get to run to building another airplane after the baby, it's going to have an airfoil tail.
In Whiteley's article where he talked about having incidence in the tail, what are your thoughts on that?
It works. In the Trivial Pursuit, it works real well.
What's
all
your
the- all the-
hypothesis
all
as
the
to why it
airplanes-
works?
I have no idea. My only guess is that it has to do with that the airplanes as built aren't in line, and because the tail is above the wing and the engine's above the wing. And it affects the airflow coming off the prop of the wing, and the angle of attack on the stabs, the effective angle of attack from the wing.
Mhm.
That's just a guess. The only way to really prove that would be build an airplane where you could vary the tail vertically up and down, get it in line,
Mhm.
or reverse it, bring it down low below the wing.
Mhm.
But it works real well. This one's got it. It's built in. It's no way to change it. And the other airplanes that
How
I
much
built
incidence
at
is it?
0-0, it's just under a degree, 0.8 of a degree. So 32nd of an inch at the leading edge with the cord and the stab there.
Mhm.
But the other airplanes built at 0-0 and measured with the meters pretty close to 0-0. Neutral stability at best. My China airplane was the worst of the bunch. It was almost negative stability. You had to fly it every single moment.
Kind of F-16 technology, huh?
Yeah, almost. And I could get to where I could fly it really good, but it was so much work and so much concentration, it was really fatiguing to fly, or try to fly well. And this thing, the airplane does all the corners and the bottoms. It's automatic.
Hmm.
A little bit of positive incidence, 90% of the hunting goes away, and you get much up over a degree, and there aren't any additional benefits over a degree. And that's when the bottoms start being flat, and you don't come up at funny angles and have climbing bottoms and the squares and the triangles.
Hmm.
And it flies straight and level, which none of the other airplanes really did. The one with the removable tail does now, after I did all the tail experiments on it.
Mhm.
But my guess is it has to do with the relation of the wing and the vertical arrangement of the stab. Do you have any theories on that?
I do, but nobody wants to hear them.
Sure.
We all want to hear them, Paul.
Go for it.
I think it's a cure for something that's not lined up right.
Could be.
I think that's the problem. But I've tried it. I've had it in mind, and I can't see those benefits. I've never.
Well, like I've been always saying, it could only work with that airfoil on that wing.
It may be. I don't know. It's.
But the other airplanes, I've measured them as close as I can measure them, and they're all as I intended to build them.
Yeah, I've used the down thrust in the engine and
Mhm.
the incidence and all that, and I found that when I went back to 0-0-0, it was
Mhm.
better all around.
Hmm.
Yeah, maybe it is something unique, but
Is your
I can't imagine that.
I was going to ask Dave, is your airfoil as per plan?
Yeah, pretty much. But the next one won't be. Next one will probably have the high point moved back a little bit.
Oh, Ted's gonna
Yeah,
disown
I
you.
know, I know.
Ted's gonna disown you. Wow.
But that airfoil is not forgiving at all of any kind of contamination on it. And if you get rain on it, weight or whether it disturbs the airflow on it,
Mm-hmm.
any kind of little bit of rain on it, and it stalls pretty violently. This one I haven't really flown it in heavy rain, so I don't know at the lighter weight how it will do. But
Mhm.
the other airplanes I have, and it does not like it
Hmm.
at all. So it'll be an experiment. See what happens.
So your hypothesis then is to move the high point further back so it's more in line with the CG, and it'll be happier in the corners and not
A little bit.
delaminating. Is that the summation of that?
Make it more like an impact wing.
Be less sensitive. To
Less
under-
sensitive to stall and
Mhm.
delamination on the airplane. The other fix would be to string wires at the high point turbulators on the top of the wing, like we did with Ted's airplane.
Mhm.
Mm-hmm.
And Jim Aaron flew his airplane
Yeah, I
at
saw
home.
that.
He
Oh,
really
at home,
flew it
at
at home,
home, yeah.
and it's much better even at home.
Interesting.
It flies through the overheads now instead of stalling through the overheads,
Amazing. Yeah.
and he can make it through an hourglass now. So he's convinced it really does do something.
Yeah.
Put wires on
Yeah.
Jim
There's
Aaron's
really
airplane
probably a lot
turbulators.
we don't know about the airfoil technology at the Reynolds numbers we're running at. It's plus with the cross flow on it because we're flying in a circle.
Mhm.
Must have some influence on this that nobody's done any
Well,
work
the
on.
debate on inboard versus outboard flap size.
Mhm.
the finesse parts of the airplane, like the fairings and fillets and things like that were ultimately proved out on full-size airplanes to be beneficial aerodynamically. Is that something that you would not consider to be a great big an influence because we're looking for high drag airplanes? Or are we giving up something in the control surfaces as a result?
No, it looks pretty.
Yes.
That's really, in my mind, as Paul said, at these speeds and Reynolds numbers that they do, is it looks pretty.
The take aparts too, it is a bit of a saddle, but
With the interference drag coming off the fuselage and the wing, I don't think fillets or fairings really are going to do that much.
Mm-hmm.
Like about a year and a half ago, there was a guy that wrote a big long article about his theory as to why the fillets on the fuselage side and the controls, how they made it better or worse in maneuvers.
What was that at the tail?
In the tail area? Yeah, you remember that?
Yeah.
I had a big long response written out for that, and I lost it. I didn't send
Chris
it.
Lella.
Yeah, I didn't send it back to Tom Morris.
Yeah. Mm-hmm.
What's your hypothesis, Paul, on side area? More is better, less is better, some's good, some in front is better than some in back?
Well, again, I tend to agree with Howard. It's the aspect ratio of your body is pretty disgusting. It's the wrong way to generate any kind of significant lift on it, but there might be.
So we're looking to generate lift with the side area, is that?
I don't think. Chris's airplane, I think we were watching it. It's got less side area than the standard impact, but once you get the trim in the right place, I think it's going to run just fine, and it's not going to have those problems. I don't know that it's a big deal. Certainly, David's works pretty well on the overheads and doesn't have a significant amount of side area. I don't think there's I think people make more of it than is there.
I think there's a lot more benefit to be had properly trimming the lead outs and no rudder offset than the debate over the side area.
Yeah.
Okay.
But green canopies, I know for a fact that they don't work.
Well, yeah, everybody knows
that.
that.
Green canopies?
Yeah,
green ones.
it's green.
You know, I was wondering,
Isn't it yellow?
was that the
It looks pretty
space
green
tape
from here.
inside?
It's the green inside that makes
No.
it look green. What's that?
Oh, the space tape inside. That's what's good. It's
Oh,
bouncing
that.
all the photons from the sun off and causing the yawn in the corners.
Think of it.
Yeah, we never thought about what it is.
Oh, yeah, you laughed at me with my deflected.
That's what that's what I know. Doesn't it flash at you when it's going around in a circle?
That may be what we're thinking is yaw.
It's
the
just the
flash
flash.
from that.
Yeah.
We better cover over your canopy tomorrow. Maybe we'll
Electrical tape.
I've got some black paint we can paint over it right now.
I was thinking of just taking an X-Acto and cutting it out of there.
No,
I'm
well,
not doing it low bottom and run it over a lake or something. There's a fish that can grab it.
that's your new method of fly fishing.
yeah, that's fly fishing. That's right.
We talked today about
How do you
trimming
do that?
being an issue that most flyers have a
He has a hump.
difficulty achieving. What would you suggest would be an exercise to
It's
go
fun.
through to
No, I was just looking at how you
to
catch
learn
your wheel
how to
pins.
trim an airplane?
How-
Rather than just playing with all the components, which of course is the tried and true process.
Well, let me tell you how I got there. It was in 1981, and I had one airplane,
Mm-hmm.
and it was a heavy airplane. I didn't have any backups. I had nothing else to make it work. And so the only option I had was to make it fly better. And I just would go out and fly. I was out flying 15 flights a day at that point in time, no kids.
We can edit that part out later if you like.
No, there were no kids, and it was I could go do 15 flights a day, and that's what I did. And so what I did is I started experimenting with all the different trimming options I had on the airplane, and you could, lead outs, tip weight, balance, flap to elevator ratios, the amount of elevator, the total throw on the elevator, etc. Propellers, fuel, all that stuff. You play with all those things. You try all the combinations of those things. And you start to get a feel for what makes things work and what doesn't work. And the only way to get there is to go through that experience of actually trying all the different adjustments on a given airplane. Mind you, you need to start and do this with a straight airplane.
Mm-hmm.
If you're working with a crooked airplane, you're in trouble because you're never going to learn the right things. You learn what made that crooked airplane go.
Right.
But you need a straight airplane to do that on. So after I got my airplane straight, that airplane had a 3/32 flap horn that was soft. And it had an anomaly that I go into the car, and when I put it in the trunk of the car, one flap would touch a little bit on the spare tire.
No.
And it was hot enough out that that horn would take a set. So I go out to the field one day, and the wing could be up like this. What the heck is wrong with it? And then I tweak it, get it right. I come out the next day, and it'd be the other way or something. Drove me crazy until I finally figured out what was going on. I had to build an 1/8 inch wire brace that I bolted to the bottom of the flap and went around the bottom of the fuselage.
Oh.
And to hold it. I mean, that was a real brace. Once I did that, that airplane was dead consistent, time after time after time. But that was forcing myself to fly that airplane, even though it was heavy. It forced me to if that had been a real light airplane, I may not have been forced into the situation of having to get the optimum trim on it to get a good flight out of it. But being heavy, it forced me to do that.
Mm-hmm.
So the bottom line is you've got to go out and do these things. You've got to move the trims and tip weights and lead outs and all of those things to learn what makes what go. And just going out there and toughing it out. If something's not right, well, I'm just going to go tough it out and make the best pattern I can with what I've got. Isn't going to advance you as far as learning how to get the plane adjusted.
Would you suggest starting that a heavy airplane is a better learning?
I didn't
program?
say that. I just said that's where I was at. That's the
No.
unfortunate situation I got myself into.
Like everybody has
But
a
it
heavy
forced me
airplane
to.
though. Not
Oh, yeah.
everybody has a light airplane.
Part of that also is not only learning, as Paul said, the different trim options, but learning that particular airplane. I've got a couple airplanes that have always flown really well, but haven't flown good until I've learned that particular airplane, and I'm talking 400 or 500 flights on an airplane to know it well enough to know that I'm going to be able to fly it well in all conditions. Now, this airplane's not there yet, but it does so well in the bottoms. That's why it's going to Kiev. That's the only reason it's going to Kiev. The Sweden airplane, I think, ultimately can fly better, but it's not as consistent as this one is in the bottoms. And flat, straight bottoms. That's what the contest is about. Or so it seems.
But stick time is what you got to get. Stick time is the bottom answer. But, sorry Bill, there's certain people out there who do a lot of stick time, but I don't think they experiment enough to know. They don't put too much wingtip weight in and see what happens.
I don't know how much Bill plays around with his airplanes.
I don't know.
He gets a lot of stick time.
He gets a lot of stick time, but it may be a lot of stick time in poor trim.
Well, I think that's an anomaly. Well, it's hardly an anomaly, but it's a condition that I was willing to accept with that airplane because I didn't know either through inexperience or through frustration with that airplane so far that it could be better. I presumed that it could, but I figured, well, I was about 95%. But with just a couple of changes that we made today, it's significantly better.
So I'm sure you'll be busy practicing with your trim
Absolutely.
next spring.
Well, yeah, it's hardly the time now, but
Right, exactly.
I found the airplane actually difficult to fly after all the changes that we made. It was foreign to me. Not that it was hard to fly, it was just
Different.
different.
I
Yeah,
don't know what you're used to. But
yeah, but was it better or not? Yeah, I think different is often confused with poor.
and different is different. There's a lot of personal styles that are involved and as to what is good. Everybody flies different.
I found that with the tail experiments too,
Yeah.
that there were a lot of things that worked well, but were different enough. I could learn to fly it that way, but I like this other tail suited my preferences better, so I just went with
What do you think the evolution is from here? Or have we reached the end?
that. Oh, yeah, never.
If you reach the end,
Well, it's the question to you. Like, I mean, do you think that control systems at perfectly 90 degrees that deflect up and down precisely 45 is going to make that much difference, or is that something that you can compensate in your mind?
Bell cranks and corn stuff, yeah.
Like in the last Stunt News, there's a lot of dissertation
Oh,
about
the exponential doctrine.
not the
but
expo.
that
No,
the
it's
one that's
about-
on the plans right there, for instance.
Yeah, like
Yeah.
you only got 45.
All
on
the other
the
impacts,
40s,
for
right?
whatever it's worth, have been straight. And that one out there now has got this stuff in it.
Yeah.
I find it much easier to do the outside squares with this airplane than any of the other ones I've ever had. And that's really the only difference. That's the only thing I can put my finger on. I built enough of these things that it's the only difference. Yeah, I suspect I'll have that in all my other airplanes from now on. It seems to work.
So,
But when you talk about differences, though, I think there's more to be had. Like what Hunt's doing, he's going to get the ball rolling here.
Well,
He's
the
obviously
Canard.
going to pay the price for it, but he's going to start out with flying a Canard, and that may change the face of Stunt as well. We'll see. I think I like the idea of it. One of the things I've always wanted to do is build one of those, but when you get into this mode of going to the world champs and all that, you can't be in the mode of developing a lot of new technology. You don't have the time for it. You're always, every other year, it's the team trials or the world champs, and you're always having to spend time practicing, getting ready for that. So it's very difficult to try and develop something new. So it's neat that he's doing that. But unfortunately, I think he will suffer on his scores at the beginning, because the judges, I'm sure, will not be used to the way it's going to fly.
Yeah.
It is quite different. But that may change. We'll see. I think that's
The perception of pipes have changed.
yeah. It's
It took a couple of years.
It's the perception of pipes has changed in this country.
Yeah.
yeah, roger that.
Don't
Well-
think it's changed in Europe.
That's, believe it or not, another reason the
Yeah.
60 is going instead of the 50.
Yeah. Mm-hmm.
Because the 60 sounds more like what they're
Yeah,
used to.
exactly. Oh, I understand. So, I like the Canard idea. I think that's something that can change the face of Stunt. And we'll see.
What's the hypothesis overlooking the fact that it may be gimmicky, the concept of retracts?
Yeah, I think that's a lot to do about nothing.
Well, both of Billy's P-47s are set up for it, and I haven't seen them in it yet.
But he's had them in it, he's used them, but he hasn't felt it's necessarily worth it for competition yet. Says they work, he can feel a small difference, but is it worth the hassle? I don't know.
Difference good, bad, or just different?
He thinks it's good, and he really wants to get it working, but he doesn't have a reliable enough system, he thinks, yet to do that. And so, yeah, if you could find a way to do it that didn't cost you any significant amount of weight and it was reliable, yeah, it looks cool. But I don't think that the type of landing gear we're looking at here is a very high drag item. This is a pretty minimal amount of drag we're talking about, especially with the carbon ones. The weight's pretty insignificant anymore. So I don't know that there's a big carrot to go after there, other than the fact that it looks cool. There's no question about that. And I like to, one of the goals when I build the Heinkel is to put retracts in it. It would just be cool. So, but it's just for
To be cool.
to
Just
be
to
cool,
see. Yeah.
jazz points, nothing to make it work any better. They work good enough as they are. I can't tell a lot of difference between inside and outside corners right now anyway. So,
Do you think you'd have to change the plan form at all for, or the decklage for retracts? Would there be any advantage to that? Like, would an inline model work better with retracts?
Interesting question.
I don't know. I know Whiteley claimed that he could tell the difference on his P-51 with the retracts going up and down. But again, he had fairings on them that were made so when it folded up to take the wing shape of the wing, but when they were down, they weren't in perfect, you know, the way you'd have them if you were blocking them down. They were kicked off that, and I'm sure they're creating a lot of drag. So in that configuration, when they're down, yeah, I can see where it might make a difference. So I don't know how fair of a comparison that is either. So, don't know the answer to that.
Well, that was a great discussion.
But I got one question left for you, Bruce.
Certainly.
Your plane's called Legend. Shouldn't it be Lay Legend for all your French compatriots in Canada?
That's why we have the leaf leaning one way on one side and the other way on the other side.
Oh, I didn't know there's a difference between the English-speaking maple leaf and the French-speaking maple
Yeah,
leaf.
it's quite distinct. Yeah.
Really? I didn't know that.
I'll
Learn
have
something
to- I'll
new
have
every
to look
day.
for that. We don't want to be raising the flag upside down at baseball games.
No, that was enough. See, and you'll notice that just behind the cockpit it says La Belle Helmet.
Les Belles.
It means it's a pretty hat.
Oh.
I see, okay. Alright, okay.
Great, thanks guys.
Okay.